Good afternoon, everybody. Everybody having a good Maker Faire? All right. Let me introduce myself. My name is Andrew Terranova. I'm with Make, and I want to kick this off, getting started to Arduino. Let me just show you by show of hands, who considers themselves an Arduino expert? Good, because you'd be bored. Do you consider yourself an Arduino beginner, newbie? Raise your hands. That's it? All right, come on. This is the right place for those people. And then how about maybe intermediate, enough to be dangerous? Yeah, me too. All right, so if you know more than me, don't embarrass me up here. All right, so what's an Arduino? What is it good for? So an Arduino is basically a little computer on a board. It's a microcontroller, a microprocessor on a board. It has inputs, and then you run a program, and then it has outputs. That's the most basic explanation. What can you do with it? Just about anything you want to. So people use them to hack old toys, do cool electronic projects. I think an excellent use for an Arduino is to learn to program. If you're not already a programmer, what could be more fun than instead of just sort of writing a generic program to create a project that has a programming aspect to it and bring your project to life. So it's a great way to learn programming. So here are a few examples. The Monkey Couch Guardian can be sitting on a couch and looking for having a sensor to sense when someone comes close. That's an input. There's a program running that's watching for that input on the sensor. And then, of course, if it sees somebody, it's going to do the scary thing, right? Well, what it's doing is it's running an output that runs and closes and starts a motor, and that's an output. So we had an input, the sensor, the programming, and the output, right? Or how about the secret knock gumball machine? Okay, so instead of putting a coin in, you have to knock in a certain pattern, and it's listening. So it's listening for the vibration or the sound. That's an input. Program is sitting there waiting for it. That's your program. And then the output is maybe it fires a little solenoid to shoot your gumball out. Okay? So again, input, program, output. Another example, a sun logger. You can have a little light-sensitive resistor in there. That's a sensor. So it goes to your input. All right, your program is looking for it. You could be logging the data. The output could be a like an SD-RAM data storage card. Maybe you're tracking the level of the sun over the course of the day. Okay? So let me just talk about a little bit more about inputs for 1 second. There are digital inputs. Digital is like 1, 0, on, off, light, dark, right? So if you had a sun logger and it was a digital input, all you know is there's light, there's no light. Arduinos also have analog inputs. That can tell you more of like a range of numbers. So how light is it? Okay, so you're going to hear analog and digital, right? That's on the input side. Now, the digital inputs can also be used as digital outputs, the same pins, but there's really no such thing as an analog output. However, there's kind of a cheat for that. On the digital output pins, you can, instead of leaving it on all the time or off all the time, you can pulse it. Now, each pulse is the full voltage output that the pin goes to, like 5 volts, let's say. But by putting it in pulses, it's on maybe only 50% of the time or 25% of the time. And you can use this to appear to be like less voltage. So for example, if you're running an LED and you pulse it, then it looks to be less than full bright. In fact, like if you see LEDs around that are like getting dimmer and brighter and dimmer and brighter, they're probably using what's called pulse width modulation on one of the digital output pins of a microcontroller, whether it's an Arduino or something else. Okay? So that's analog and digital. Okay, where can you learn about Arduino? A great place to learn about Arduino is Arduino's own website, arduino.cc. They've got references to all their commands, they've got examples, tutorials, and I often go back there myself and refer back to it. There are also some great books, and there's other websites. In the Maker Shed here, we have Getting Started with Arduino. There's a Getting Started kit if you need to buy your first Arduino, and there's also, I like to make robots. That's what I love to do. So you can get a book about making Arduino robots, which is a really good book. But there are lots of examples out there. Just search for them. They're out there. So let's talk about the boards. There are a lot of choices, and I don't want to make this too confusing. So here are like some 4 of the basic boards that you might choose. The Uno, if you just kind of like want to learn Arduino, that's a good place to start. Okay. Most of these boards run at 16 megahertz. That's the clock speed of the processor, not too important to know. But the I/O, the input-output, how many pins you have, that's kind of important. The Uno has 14 digital input-output pins, 6 of which can do PWM, that pulse width modulation, or lying to you about how much voltage they're putting out. And they have 6 analog inputs. The analog inputs are only input. Okay? Okay, if you need more for your project, if your project has a lot of I/O, a lot of things you want to monitor, sensors, or a lot of outputs, then the Mega is a good choice. It's a slightly fast, well, it's the same speed processor, but it's a processor that can handle a lot more pins and memory. So, and it has 54 digital I/O pins, 15 of which can be PWM, and it has 16 analog inputs. So, the basic idea is, hey, if you want to have a lot of I/O, the Mega, good choice. The Leonardo is a different processor. It also runs at 16 megahertz. It has 20 digital I/O, 7 can do PWM, 12 analog input. It has some built-in USB capability, so that might be a reason to go towards that board. It will not, you're going to hear a term called shields. A shield is an expansion board that pops right on top of your Arduino to provide new functions. There are some shields that use a protocol called SPI that the Leonardo is not compatible with. So just be aware of that if you're going down that route. All of those 3 boards use 5 volts. They interface at 5 volts, okay? The Due is different. It runs at, it's about the size of the Mega in terms of I/O, 54 digital input outputs, 12 PWM, 12 analog, but it runs at 3.3 volts. This is important. Some sensors run at 3.3 volts. But if you choose the Due, then you're going to be dealing with a 3.3 voltage for your pins. If you plug something that runs at 5 volts into it as an input, you might burn out your pin. You could burn out potentially the whole board. So, but you might want that board if you know that the sensors, let's say, you're using are 3.3 volt sensors. So that's the reason to go to that board. Okay. There's a few new members of the family, relatively new. The Arduino robot, it's got like 2 boards on it. I think there's actually 2 Arduinos built on. It's got motor drivers and sensors and stuff built right on the board. Comes as a kit with wheels and everything. And it's all in one package. And then the Yun is new too. It was announced in May at Maker Faire Bay Area, and it's available, I understand, for sale in the US for the first time here at Maker Faire at the Shed. The cool thing about the Yun is it brings in Wi-Fi capability, which a lot of people have an interest in. Also, it has sort of another little processor on there that's running Linux. It's a version of Unix if you're not familiar. And some people want to be able to have that capability. There's a whole bridge module that lets the Arduino speak talk to the Unix speak. So again, I'm just going to touch on it so you're aware. If that's an interest, look up more information. Okay, now there are just a few other boards that you might be interested in. It's the Esplora, the Arduino Ethernet, the LilyPad, the Micro, the Nano, the Mini, the Pro Mini, and the FIO. Everybody got that? No? Okay, that's all right. There's a lot of boards, and you might choose them for a specific reason. Like the Esplora has some built-in sensors, like little buttons right on it. Let's say you wanted to make a little game controller or something. It's got some buttons built right on it, right? So it's a nice little thing for that kind of project. The LilyPad is really cool. It's that little round one in the middle. It's like about this big. It's great for making like a badge or a wearable or something you sew into clothing or a teddy bear. You can actually, it's got like holes. You can actually sew it in. So that's kind of made just for that sort of project. If your project, if you know you want to interface your project with Ethernet, the Arduino Ethernet is a choice. If you had an Uno or one of the other boards, you could also pop an Ethernet shield right on top and get that Ethernet capability. I'm not going to go through all the differences of like the Micro, the Nano, and all those. They run at some different voltages. They're small, compact. They're good for embedded projects. The only one I'll mention specifically is the FIO, which has a wireless protocol known as XB. You don't need to know what that is, but if you do know what that is and you want to play in that world, the FIO is a nice choice for that. All of these, the product information for all of these and all the specs are on Arduino's website. Just click on products, and you'll see all these boards. Okay, let me just take you in detail through the Uno. There's a reset button. Along the top, there's a header pins. Those are called header pins. That's where those digital I/O pins I talked about are. In the sort of the bottom corner there in the middle-ish, that long chip is the brain. That's the processor. Along the bottom row of headers, those are power pins, as well as the analog input pins. And then along the side is USB power. You also, when you interface to your computer to program it, you also plug in there. And that is, usually when you're like working with it, you might power it from your computer while you're working on it, and then later on you might want to have it somewhere and run off batteries or like a wall wart, a power plug, and then you can plug it into the DC power jack. Okay, the shields we've talked a little about. There's shields for lots of things: motor drivers, servo drivers, LED drivers, all kinds of cool stuff. Or like this one's like a prototyping board. You can make your own circuit. Lots of choices. If you have a project you want to do, and you think you might need a shield, search for it. They're open source. People can make their own shield. So maybe someone's done your shield already, or maybe you want to look up the specs and make your own. Okay, what you need to get started is a computer. That's where the programming happens. You need a cable, and you need the actual Arduino. The software is free. It's available for download on Arduino's website. It looks like that. And there's example programs in there. You load the program or write it, you compile it, and then you basically download it into your little Arduino, and then it runs. There's a basic program that comes with the environment called Blink. If you know programming and you know what Hello World is, that's like when you first learn to program, people learn the Hello World program. Blink is like the Hello World of Arduino, right? If you first learn. The cool thing is, you get this, you don't know how to program, you never use an Arduino, you load the Blink program and the little onboard LED starts blinking. You're like, I did it. But then you look at the program, you're like, well, okay, how do I make the LED flash faster or slower? How do I make it use PWM and make it pulse instead of flash? Or how do I add a sensor and have the LED respond to my sensor, a button, a mic, right? So there's input, your program, and the output. Forget the LED, run a motor, run a servo, run whatever. Those are all your outputs, okay? I kind of talked through this. This is what it looks like. We're loading an example sketch. That's the Blink one. It's simple. I always forget to say the programming language itself. Don't get too scared. It's C-like. If you know C programming. If you don't know C programming, there's a lot of examples and tutorials, so don't worry too much. There's some scary-looking, squirrely brackets. It's not that hard, really. But there are also these libraries, right? And the libraries might do something like control a servo or a motor, and the code can be hidden from you and simplified. You don't have to worry about it. But if you are a programmer and you want to learn about it, you can open up the library, look at it, modify it, write your own, whatever. So it kind of hides some of the ucky, scary stuff if you don't want to see it, but it doesn't keep you from it if you want to dive right in. That's my whole presentation. Do we have time for questions? Check the time, hang on. I think we have time for questions. Yeah. Oh boy. He asked how much money like an Uno costs. I don't actually know. I think it's like 30, 40 bucks, but I'm not sure. They're selling them over at the Maker Shed. They can tell you for sure. I'm sorry, I don't know. Anyone else? Yes? Oh, that's a great question. The next presentation is going to be on the Raspberry Pi, so you'll hear all about it in just a second. Anybody else? All right, thank you all very much.